This is Shop Talk. The F in your G code is the number most operators guess at. And that guess is why your end mill snapped. Your finish looks like bacon, and your insert lasted 20 minutes instead of 2 hours. Here's the line everyone types. F18, S3500, 2000 inverse minutes. Looks fine. Tells you nothing about whether the tool can survive it. Chip load is feed rate divided by RPM divided by number of flutes. That's the bite per tooth, and it's the only number the cutting edge actually feels. Quarter inch, 4-flute carbide and aluminum wants somewhere around 0.002 per tooth. At 10,000 RPM, that's 80 inches per minute. Type F30 instead, and you're rubbing, not cutting. Rubbing is the killer nobody sees. The edge doesn't shear the metal. It smears, work hardens it, then chips. You blame the tool. The tool was fine. Your feed was too slow. Slow feeds don't save tools. They cook them. On the other end, push F past what the chip load chart allows, and the flute can't evacuate. The chip recuts, jams the gullet, and the tool grenades. One bad line, one scrapped part. Sometimes one scrapped spindle. Here's the window. Below the minimum chip load, you rub. Above the maximum, you break. The whole game is staying inside that band, and most shops never check where the band actually is. Every carbide manufacturer publishes the band. Kennametal, Harvey, Niagara, OSG, they all give you a chip load range per material per diameter. It's free. Nobody reads it. There's a second thing the F number hides, chip thinning. When your radial engagement drops below half the tool diameter, the actual chip gets thinner than your math says. You need to feed faster to compensate. At 10% step over, your effective chip is roughly 60% of programmed. So if your chart says 0.002, you actually need to program around 0.0033 to hit it. This is why finish passes burn tools. My take. Most operators were never taught chip load. They were taught feeds and speeds as two numbers handed down from whoever ran the machine last. That's why the same shop runs the same tool at half its rated life and calls it normal. The fix takes 90 seconds. Pull the tool's chip load range, multiply by flutes, multiply by RPM. That's your F. Write it on the program in a comment so the next person doesn't guess. Like this. The comment locks the math, so the next operator doesn't undercut it on a hunch. Listen to the cut too. A correct chip load sounds steady, a clean shear, not a scream and not a chatter. If you hear the pitch wander, the chip is wandering with it. Right chip load, right sound, right tool life, all from one number you actually calculated. If you've made it this far, you're already past the operator who's going to break a tool today guessing at F. Subscribe. Shop Talk drops one of these every week, and the next one keeps your spindle alive.